Welcome to Khan Academy. My name is Trevor McKay, and today I will be explaining the Event Horizon Telescope, what it is, what it does, and why it's special. The Event Horizon Telescope was designed to image objects that normal telescopes cannot perceive, specifically black holes. Before I explain the way that the Event Horizon Telescope is able to do this, we must first acquire a basic understanding of what a black hole is. A black hole is the result of mass being compressed, similar to how a trash compactor works, to an extremely dense state in which this mass collapses in on itself, eventually growing through a process in which it pulls in and consumes other matter floating by it in space. In the case of massive objects, such as planets, stars, or black holes, their gravitational pull can be incredibly large and will affect the ability of particles or matter to escape beyond it. For this reason, a certain speed, or escape velocity more properly, has to be reached to escape the pull of a large mass's gravity. What makes black holes so unique is that due to their enormous mass, after all, certain supermassive black holes contain the mass equivalent of over 1 billion of our suns, their escape velocity is actually greater than the speed of light. Even light cannot get beyond a black hole's gravitational pull, giving the effect of an infinitely dark center in the black hole its name. This process can be viewed in the accretion disk of a black hole, in which particles orbiting around a black hole begin to lose momentum and fall towards the center. The event horizon, also commonly referred to as the point of no return, is the theoretical boundary past which nothing can escape a black hole's gravitational pull. As seen here, the center of the black hole is dark, but is surrounded by a very bright accretion disk. Black holes come in two forms. Massive black holes is the first form. These exist at the center of every galaxy. And two, the second form, stellar mass black holes. These are formed naturally at the end of massive stars' life cycles. Only 0.05% of the most massive stars eventually become black holes. And this is currently the only way we know of a black hole being formed. It can be useful in estimating how many black holes may exist across the universe based on how many stars there are. Now that we know what a black hole is, how do we find them? While there are many different techniques used for locating black holes, all depend on advanced telescopes. The simple principle of telescopes is to increase the size of a faraway object so it can indeed be seen. And when using telescopes, we need to be mindful of two important things: how far the object is from us and how big or bright it is. The general rule is the bigger the telescope, the further away one can see with it. The spatial resolution of a telescope is the smallest object it can sense or perceive. The smaller the spatial resolution, the more powerful the telescope. Although black holes create large and bright accretion disks, they are incredibly far away, and thus difficult to image with traditional telescopes. At least, that was before the creation of the Event Horizon Telescope. The Event Horizon Telescope project was launched in 2009 with the goal of locating supermassive black holes and getting the first images of them. Recognizing the limitations of individual telescopes to increase their spatial resolution past a certain point, similar to the law of diminishing returns, this international collaborative effort organized and constructed a global array of 9 large radio telescopes that work in conjunction to, in essence, act as a single collective telescope and greatly expand the distance of our reach. Prior to the Event Horizon Telescope, the best telescopes available, such as the Hubble Space Telescope, had a spatial resolution of 0.1 arcseconds. The Event Horizon Telescope, however, using its global network, is able to create a telescope effectively the size of the Earth's diameter that is able to achieve a spatial resolution of 0.000005 arcseconds. This leap is truly incredible and has allowed researchers for the first time to see and take images of supermassive black holes millions of light years away from where we are. As of today, the Event Horizon Telescope has imaged 2 black holes: the supermassive black hole at the center of our Milky Way galaxy, designated Sagittarius A star, and the supermassive black hole at the center of the Messier 87 galaxy, which resides in the constellation Virgo. It is this second supermassive black hole that was the first to be photographed by the Event Horizon Telescope. Here's an image of this black hole's accretion disk. The Event Horizon Telescope is revolutionizing the way that we understand our universe. Researchers continue to expand their knowledge of black holes, how they work, and what they are. This radically improves our understanding of the universe we live in and helps to further possibilities of future scientific discovery. Thank you.